Hi guys, this is your Uncle James. My understanding is that you young people have apps that make you enhance your appearance when you make a selfie video. But I don't have one of those apps. So here goes. This is Uncle James's video to try to explain some simple math to show why stay home matters. Because reducing the number of people that each infected person passes the virus to, even a little bit, has a huge effect on the total people infected in a short time. Here's the math. It's simple. That's the equation. C times R raised to the P equals the number of infected people. Let's go through that. C is the number of people infected today with the coronavirus, COVID-19. So that's a number that changes every day. But it's a starting point for the calculation. R is the rate or the number of people each infected person infects in a given time period. P is the number of weeks, or really, it's the periods in which infections occur. So in other words, P is a number that means it's the number of times you multiply the rate times itself, which is what exponents are all about. And so the reason P is expressed in weeks in this calculation is because the coronavirus pretty much seems to have an infection rate right now of around 2 people per week. In other words, an infected person will, if they do nothing, will infect 2 other people over the course of a 2-week period. So in that time period, the average infection period is 1 week. So using the equation we discussed previously, let's say on March 21st, which was yesterday, 2020, which is this year, let's look at some alternate scenarios. So remember the equation. It's C times R raised to the P. C, as of yesterday, is the number of people who were infected across the whole country. Yesterday, they were saying in the New York Times that it was 17,500 people who currently have the coronavirus that we know about. There might be more, but let's just start with that number. So R is the number of people infected people are giving the infection to during the 2-week period during which they are contagious. And that number right now seems to be about 2. So in other words, a person with coronavirus seems to be infecting about 2 people on average over a 2-week period. And then for P, this is the one's a little tricky. P, you can pick any number because what P is the number of weeks you're wanting to look at. So in other words, with exponents, you're multiplying the number, the R number, times itself every period of time that you're looking at. So in other words, if the R is 2 people who infect each of those 2 people infect 2 people in the course of a week, that's 2 squared, so you would use 2 for P because that would be 1-week period. But then if you go to 2 weeks, then you're going to use, you're going to go for 2 periods, then you're going to go for 3 because that's 2 That's the original number times itself again. So that would be a 3-week period. So if you do 5, that's, I guess that's only, well, it's a 4 or 5 week period. Now I'm a little bit confused, but anyway, you get the idea. So 17,500 times 2 to the 5th, which we're saying is 4 or 5 weeks. It doesn't really matter because that's kind of an estimate anyway, would be 560,000 people infected in about 4 or 5 weeks. So what happens if you change just one number, which is the number for R, which is the rate of infection, and you change that from 2 people in that 1-week period, you change it to 1.25 people. So now each infected person only infects 1.25 people during that same period of time. And that's because they stay indoors, they don't go out, and they basically try to keep social distance. So on average, all the people who are infected are now infecting only 1.25 people in that 2-week period that they're contagious instead of 2 people. What happens? It's the same 5-week period, 17,500 people times 1.25 raised to the 5th. If you do the math on your calculator, you'll see it's only 53,405 people who are infected at the end of that period. So that is about less than 1/10 of the people being infected. 10 times less. So that's a huge difference, and it's basically because people are paying attention to keeping social distance and not infecting each other. So that shows to me that this can make an enormous difference. Now, if you want to try this math yourself, the things to play around with, well, you can play with the start number depending on what you find out is the current number of people who are infected. Like so, yesterday it said 17,500. By today, it's probably quite a bit more than that, partly because they've been doing a lot of mass testing and partly because the number keeps growing. So you could plug in today's number if you can find it in the news. And then for the R, for the rate of infection, you could try different numbers. And for the exponent, which is the number of weeks, you should try different weeks. So try a 6, try a 7, because the reason is you'll see that it doesn't take very long for that number, especially if the rate of infection is 2 or higher, that number will get into the millions really, really fast. So we can go into more of the basics of exponents later, but the best way to try out the basics of exponents is just to take the number and multiply it times itself over and over again instead of using your calculator. And that is why it makes a difference to do social distancing.